who is the Chief Executive Officer, Chief Technology Officer, and founder of Fiorano Software since 1995. And he brought a vision of an architectural revolution to the realm of business integration. And now for over 2 decades, the tool has been at the forefront of integration and SOA, with continuous innovation in our products from the days of basic messaging, introducing one of the first commercially available JMS standards middleware products, through the mid-90s with our successful ESB offering, and through the present with our API management and peer-to-peer distributed processing products. He is also one of the first entrepreneurs to realize the power of microservices early on, a critical architectural decision in redefining today's digital world. So with that, I'd like to introduce you to Jason Bloomberg, and Jason will set the stage for the rise of open source enterprise service bus. Thanks very much. Take it away, Jason.
Well, thank you very much, Tom. Let's see if we got the control going here. So it's a pleasure to be here on the another Fiorano webinar, and somebody needs to hand me the control so I can advance the slides. So while I'm waiting to get control of the slides, I guess the first slide will be introducing myself. And as Tom said, I'm, there we are, president of Intellyx. Yep. Okay, we jumped ahead. Let's see if I can get this going here. There we are. Okay. So a bit about me. I'm president of the industry analyst firm Intellyx, and I write about agile digital transformation, which is also the title of my new book coming out in 2017. I'm also publishing a new poster, if you remember my posters from ZapThink, the Agile Digital Transformation Roadmap poster. So I'll have a little more information at the end about how you can find out about that poster. So the talk today is on the open source ESB, and I know a lot of people on the call, you know, the millennials in the group may have only been working since the mid-2000s, so let's have a little history lesson about how we got to where we are today. So if we go back to the dawn of time, aka the mid-1990s, and look at the situation that middleware was in at the time, there were middleware applications, right? We were integrating different pieces of technology together, and there were technologies like message brokers that were already on the market by then. But these were all essentially tightly coupled, right? You hand-coded the endpoints, and you established the message routes, and you were able to integrate different pieces of technology together. Application servers came on the market in the late 90s, and they included integration technology to some extent. You could connect to databases and then to a limited extent to other applications. Asynchronous bus technology also came about at this time as well, where you were able to move messages along with in an asynchronous fashion, so that you know, there weren't any blocking applications. So enterprise application integration began as a pattern, soon became a technology category, but the EAI category was essentially represented a tightly coupled integration. So by 2001, the overall integration community realized that we needed a better way of integrating technology. We needed a more loosely coupled approach, and we looked at Corba, which had established a certain amount of penetration into the market, but it had its issues. So Corba is the common object request broker architecture, and essentially it was a way of moving objects like Java objects around, but it did have a service interface notion where you were able to interact with an abstracted interface, and so that basically what we did at that point is the community got together in the W3C and a few other standards bodies and hammered out the web services standards. So took the best of Corba, took XML, which had by 2001 had achieved a good measure of adoption, and put together a set of XML-based standards for building service abstraction and we called these web services. So the web services craze lasted for a few years, and the focus was really on what you could do with these services. But clearly the challenge of integration was a part of the story. The services were a way of connecting pieces of technology together. So middleware vendors realized that there was an opportunity here, and Gartner coined the term enterprise service bus. So at that point in time, basically they were putting together a few different words. This was an enterprise middleware, so there's the word enterprise, bus technology from the EAI days, and then they put the word service in there because everything had the word service. This was the web service craze, so everybody had to use the word service. So, but in the early days, there was a variety of different middleware technologies that all now got on the ESB bandwagon, and it was just take this older middleware and put web services on it, call it an ESB because that's what Gartner said the market was called. And so you had a real confusing mishmash of different technologies. So that's what was happening in the commercial space. But what about the open source space? Well, there were a number of open source efforts to build integration technology, so that became now open source ESB efforts. But keep in mind, this really is enterprise middleware, and enterprise technology is difficult to build, right? It takes a lot of time, takes a lot of effort, and so for open source efforts that are primarily driven by volunteers or by people assigned by vendors to drive open source development, it takes time for open source technologies to mature. So in the early days of web services, there were some open source products, but they weren't very useful because they just hadn't matured yet. And their reason for being was often to implement open standards, but the standards themselves were also maturing. So the early days of web services, we had early versions of SOAP and the other standards, and those weren't very mature, so the open source products that implemented them were in part slowed down by the fact that the standards themselves had yet to mature. So by 2005, we had a reasonable idea of what an ESB was supposed to look like, and it's essentially a traditional piece of on-premise middleware. So the bus is in the middle, it's fundamentally a hub and spoke architecture, and it is able to connect via various endpoints to various pieces of technology, both front-end technology as well as back-end technology, and you're able to expose web service endpoints as well as other kinds of endpoints, and then it abstracted the message routing and abstracted data transformation and security operations so that you could rely upon the ESB to do this for you. But if you look at this picture, especially if you're one of those millennials I talked about whose careers essentially have always been in the cloud, you look at this and you say, well, this is not very cloud ready, right? It's centralized, it's installed, it's on-premise, it's not going to scale horizontally, it's not going to be easily distributed or easily multi-tenant, right? This was all before the cloud, right? These technologies are essentially 1990s technologies updated for the early 2000s. This was before the cloud hit the scene, so we really weren't thinking about any of those cloud-based architectural principles at this phase, the 2005 phase. So by around this time, 2004, 2005, up through really the economic downturn, the 07, 08 economic downturn, this was really the heyday for service-oriented architecture. So web services and service-oriented architecture are connected, right? Service-oriented architecture often relied upon web services, at least the first generation of SOA relied upon web services, but SOA as an architectural approach for abstracting endpoints and supporting flexible business processes in the enterprise. From the vendor perspective, from the middleware vendors, it was a way to sell more middleware. So the vendors jumped on, the big guys jumped on to the SOA bandwagon. It was the web services bandwagon, now renamed SOA, and started telling their big enterprise customers, well, you want to implement SOA, you've got to buy our middleware, and their products continue to grow. And we call this the kitchen sink approach. So if you look at some of these big vendors, they continue to acquire many, many companies who had built some web service this or web service that, threw them into the sink, and you ended up with these big monstrosities of poorly integrated moving parts that were called ESBs or SOA suites or whatever the vendor wanted to call them. And they were difficult to implement, they were bloated, they were inflexible, and this was all before the cloud, so they had none of these cloud they followed none of the cloud best practices. So at this phase then, the open source efforts essentially became a reaction to this kitchen sink middleware approach that the big commercial vendors had taken, because the open source world is much more about focusing on streamlined technology that is, hammered on by so many people that you can really build quality software, but it tends to be narrowly scoped. So instead of having these big monstrosities, you ended up with narrowly scoped pieces of middleware that in large part were better quality than the big vendors' products, but did less in each individual product. So you ended up having to build a solution by assembling different pieces of middleware together. But by 07 or 08, a lot of these products had relatively matured, and the market had consolidated a bit, so there weren't quite as many of different open source projects out there. The list had gotten shorter at this point in time. Okay, so by 2009 then, a lot of enterprises were getting fed up with this vendor story about SOA. The way to do SOA is buy all this big heavyweight middleware, and that, it was difficult to implement, and a lot of times the whole focus on architecture was lost. And at this point, my buddy Ann Thomas, who was at Burton at the time, now she's at Gartner, wrote this wonderful blog post called SOA is Dead, Long Live Services. And it's amazing. It became a meme immediately, and all these executives read the first 3 words, SOA is dead, and thought, oh, well, SOA is dead. Why are we spending all this money on SOA? But that actually wasn't her point. The point was the focus really had to shift on implementing services properly, not about implementing middleware. That shifted the focus on SOA. We'd been through the economic downturn, so budgets were being cut. If SOA efforts hadn't paid off, if they had just turned into things, they were often, the money was now invested in other places, and there was a new, thinking about how to deal with enterprise integration. So at the same time, the cloud took off, right? So cloud computing became a reality, both the SaaS efforts as well as the IaaS, infrastructure as a service efforts, and now we became more familiar with some of these cloud best practices, the architectural best practices of horizontal scalability, decentralization, and how we're dealing with failure, right? Instead of building high availability systems, we're building highly resilient systems that respond well to failure, so they automatically recover from failure, and that's a very different way of thinking about failure than we had in the previous generation of technology. So all these traditional ESBs, what I like to call bloatware ESBs, the commercial ESBs, weren't architected to follow these now new best practices. So all these vendors really struggled, and they're still struggling to reinvent what it means to do integration in today's cloud-centric world. So this gave now a new opportunity for open source, because open source is, because these are more streamlined products that are doing less but doing it better, they're better able to move forward into the cloud, and that's essentially what happened with the open source world in terms of the enterprise integration world. So if you look around today, cloud friendliness, following core cloud architectural best practices is now a prerequisite, right? You would never buy middleware that is centralized and has to be installed on premise as the only option. It's just, why would you ever do that, right? You start with the cloud as a prerequisite. You might use integration platform as a service, or you may use some sort of cloud-based open source, a cloud-based installation of an open source product, depending upon your needs. Either way, you start as the cloud as your starting point. So a lot of the open source vendors now have matured their products, and if you look at what, say, Mule, Red Hat, and WSO2 have done over the years as their products have matured, well, they're sort of following the commercial vendors and taking this kitchen sink approach, where they add more different capabilities to their suite and coordinate the suite and make sure the suite is well integrated. And if you need the power of the suite, you need the rules engine and the business process stuff and the other elements of some of these suites, then these products can make sense, but they're reasonably cloud friendly but come with baggage, right? They meet the needs of certain organizations, but they're more heavyweight than we might potentially want from our open source products. Now there are other sort of cloud-born open source products as well that are playing in this enterprise integration space, and a lot of these focus on message queuing technologies, so ActiveMQ, RabbitMQ. These are very lightweight. They're relatively mature now. They do a few things very well, but they're very limited in the scope of what they can do. So if you're looking at the integration challenge from the perspective of an enterprise, where you want all of the cloud benefits of horizontal scalability and high resilience, but you also have the security and governance requirements that is part of the enterprise context, then these lightweight open source tools may not meet your needs. So what we have here is now a real opportunity in the market, right? We have the heavyweight open source products that meet the needs of certain companies who really need all the moving parts. You have these very lightweight tools that solve, point problems, getting messages from here to there. But in the middle, there's this real opportunity for cloud-centric, cloud-savvy open source integration technologies that bring an enterprise context but are still lightweight. And that's essentially the opportunity now that Fiorano has decided to fill. So that's a great way to set up the Fiorano story. So there's a copy of my older book that's still available. You can buy it online, and if you want a copy of this deck, you don't have to wait. You can simply send an email to nobloat@intellyx.com. That's an autoresponder. You'll get one and only one automated response, no mailing list, it's all automated, with a link to the deck. If you want to sign up for our newsletter, there's a link to do that as well as some information about where I'm appearing and a few other things. So feel free to send an email. I know you all have your phones, you've been playing with them while you've been listening. So send an email to that email address and you'll get the deck. And at this point, I'll turn it back over to Tom, who will introduce Atul.
Yes, and thank you very much, Jason, for your insightful presentation. I think that kind of makes it clear where we stand today in the marketplace with respect to our open source ESB opportunities. I'd now like to introduce Atul Saini, the Fiorano CEO, CTO of Fiorano Software. And Atul's going to discuss Fiorano's innovative approach to the open source ESB opportunity. So Atul, take it away.
Hi everybody, this is Atul Saini and I'm going to be talking about the Fiorano Community Edition. So let's start with the core requirements that you have for enterprise level middleware. I mean, there's a lot of middleware out there, and the existing open source products have been filling some niche, but really high-end enterprises have a lot of requirements that go beyond what the current open source products offer. First thing is on scaling. You have to scale linearly across commodity hardware. Right there, most of the architectures are hub and spoke architectures, and scaling them is just not particularly easy. Unless you're built ground up in a sort of in a peer style fashion with some kind of centralized control, it simply isn't easy to scale. The second point is fully asynchronous operation. You see, you have to have interactions to scale must be natively asynchronous. You can build synchronous interactions on top of an asynchronous core, but you really can't do it the other way around. This is just a lesson that people learned over time, and you have to take my word for it. Cloud readiness, a single design. You have to have a single design that can map onto enterprise internal enterprise scaling requirements that can scale across half enterprise, half cloud, a hybrid environment, or just a cloud style environment. You shouldn't have to change the architecture or change the product. The product should work very seamlessly across all three of these things, and that's really not something you have even in most commercial vendors. And then from a feature set standpoint, integration is not just about picking up a message from one application and sending it to another application with a transformation in the middle. There's a lot of things you need to do to achieve enterprise levels of features. Enterprise, if you really want to meet the requirements of a lot of enterprises, there's a lot of things you need to do. Monitoring, tracing and logging. You need to monitor across different machines, across the whole system. System is not just on a single box all the time. System is typically on distributed. Part of the interactions may be on a server in London, another may be across a server in New York, and it might be one application running across 5 different geographical locations. One logical application, right? So you have to monitor in a distributed environment, tracing and logging of information, presence and availability, where are the services, where are they running, when, how did they get there? Security, scheduling, dynamic deployment. You don't want to, especially across a network, services need to be deployed dynamically like agents. You shouldn't have to do any kind of manual work, which is something you typically find out after the fact. Location transparency, external routing, and of course really powerful visual composition tools. So there are a few issues with existing open source integration products, just a very, very general level. Typically there's a lot of coding required. Most of the time, especially in the initial stages, open source products were sold as a way of just increasing the consulting. The whole idea of having an integration product is to decrease the time it takes to do integration, not to increase it. But that really wasn't the case earlier on. Granularity, service granularity, this is an age-old argument. Is it, should the service granularity be small, coarse-grained, or fine-grained? Fiorano takes a coarse-grained approach, and that's worked very, very well for us over the years in terms of productivity. Then learning curve. The learning curve can't be too steep. You need to have a reasonable learning curve. The tools have to be intuitive. All these things add up, right? The internal architecture. Some products have, message-based architectures, but they're not really built on a scalable JMS style. JMS is actually a standard that was released in 1998 by Sun. It's called Java Message Service, but it doesn't mean just Java. JMS has really come to mean a server, a messaging, an asynchronous messaging server that supports both publish, subscribe, as well as queuing in a single server. It's a very well-designed API, but the clients, the components, the services that use this API can be written in multiple languages. Java, C, C++, C#, and Fiorano supports all of those. So you have a multi-language, multi-platform style architecture, right? And being based on a JMS style distributed architecture is important because that's really got a lot of scalability concepts built into it. And when you hit enterprise scale, you might suddenly get stuck, right? So enterprise requirements coverage, like I said, there's a lot. We're going to go over that. It's fairly patchy. Peak performance. What happens when you have an enterprise requirement where suddenly there's a massive spike in the number of messages coming in. You don't want your ESB to die, right? You can work a lot of times, but for most of the time, but when there's a peak performance, you might have a problem. So overall, the support for a lot of the existing enterprise requirements is fairly patchy. So what do we have at Fiorano? To introduce the community version, there's the ESB server, which is really an OSGI container built on Karaf, and it's a manager and a runtime for microservices. And the services that are deployed on top of the server can be written in multiple programming languages. We have Java, C, C++, C#, and there's a microservices development toolkit with visual tools for all of these languages. So you can actually have a single application where you have Java service sending a message to a C++ service, to a C# service, to a scripting service, and it's all very seamless. You just drag and drop the services from a visual tool. So you have a studio-based visual tool. This is exactly the same tool as you get with the professional version of the product with the existing Enterprise Edition. The messaging engine, it works with ActiveMQ by default today in the Community Edition, but it accepts any of the enterprise scale messaging engines, Fiorano MQ, IBM, TIBCO, a number of them, really, RabbitMQ. And there's a dashboard. There's a dashboard for monitoring as well, built on HTML5, and it's modern technology. So you're not just left high and dry with just a server. You get a number of tools to work along with the product. So what are the key integration features? It's the Fiorano servers. The Fiorano technology is built on a peer-to-peer architecture with centralized control. So the peers, services connect to peers, and the centralized controller, which you can sort of see in a red box over there, is only for control information. It's really just to give you an idea, to monitor the information flow across the various peers. The services connect to each different peer, and the peers could be in different geographical locations. So you could have one peer literally in one country, another peer in another country, and everything works seamlessly. Single architecture scales over the cloud, enterprise, or hybrid requirements. You don't have to change the architecture. Everything works whether it's in the cloud or in the enterprise or half and half. All of the components are built as coarse-grained microservices. The internal API used by the microservices is the JMS API, to which we have client bindings in Java, C, C++, and C#. So you can build coarse-grained components in any of these languages, right? Once again, it should be noted that the granularity is coarse, and this is something that has a lot of benefits. So what are some of the features? Let's talk about some of the enterprise level features that we're talking about, some of these are present in all the ESBs, but some of them are not. External routing is a great example. Location transparency, the way the system works is, you might have 10 services across distributed locations participating in an integration flow. But external routing means that each service only publishes messages to its local folders on its peer, and a target service only subscribes to its local folders. So the components are actually unaware of any of the routing. How the information actually gets routed between the peers is completely independent of the publishing of the information. So what this does is at runtime, you can simply change the routing dynamically. You can dynamically alter the system without stopping it. This has tremendous benefits at the time of development, the speed of development, in testing, for instance, right? So components are actually completely oblivious to the fact they're even participating in a distributed application. So the best of our knowledge, we're the only ones that actually do proper external routing, and having an asynchronous core architecture is critical for that, especially an asynchronous core architecture that scales across geographical locations or scales across different networks. Right. Then tracing and logging. This is something that's a fairly common feature. The output trace can be updated and routed to any node, again, across the network. Your runtime updates of trace levels. So at runtime, you can change the trace level and get more information, or you can decrease the information. This is, again, a very critical feature for debugging of processes, especially, once again, in a sort of distributed environment. Presence and availability. Went too quick there. Availability of different components across the nodes. So you might have different services deployed on different nodes, and you can find information about what's where. Monitoring and launching. Launch and relaunch components in any node, monitor what's running, what's not running, get real-time alerts. All this information is available in the dashboard. This is where, again, you save a lot of time in the development. The whole idea of an enterprise level tool is you want to get the integration done fast. You want to get it done accurately with high quality in as little time as possible. This actually, again, sometimes I must say that it goes against the traditional mindset of increasing the consulting all the time, selling man hours. So the goal over here is to decrease the man hours and increase the productivity, which is what the end customer likes. It's not necessarily what large system integrators like. So it's a sensitive issue, it's a political issue, but it's something that really needs to be addressed, because this is sort of the concept that is sold to the end customer, that you're going to cut your time down, but it never seems to happen, right? But with Fiorano, it really does. This is the one thing that everyone who's ever used this product says, is that its the productivity is very high. Security. The administrator define attributes for components, access control. They can be set in a centralized way, distributed to each peer server over the network, and with various levels of a significant number of levels. The details are in the documentation. It's something that you can download and play around with. All this is fully available. Deployment. Now, once you have a network or a cloud-based system with distributed peers across the cloud, you have to, at the click of a button, be able to deploy a service from a centralized repository. Remember, there's a centralized controller, right? The controller is just a place where you create your integration flows, and each component in the flow can run on different peer servers across the network or the cloud. And when you decide to run that flow, the controller can send the different components to the different peer servers like agents flying over the network and installing themselves. So you have an automatic deployment of all the services over the network in a full agent-based manner. And this is again something that is fairly unique because of the way the system is architected from the ground up. It's not something that you normally find in a lot of existing products. A lot of these features are driven by the fact that the underlying system is completely asynchronous. None of this stuff would work particularly well if everything was synchronous. You see? So the system being asynchronous under the covers and fully asynchronous in a very scalable manner is a very important thing for enterprise level scalability. So what are the benefits? Enhanced speed and control. Remember what I said? You're going to get things done a lot faster. So you should use Fiorano only if you want to get the job done really quick. I mean, using Fiorano and taking twice the time that you're normally taking, that would be very, very strange. And if that's the goal, then you shouldn't use the product, right? The product supports runtime process changes in practice. So while the system is running, you can pause, resume, or even add steps to the process at runtime. You don't have to stop the system. It's not like BPEL where you stop the system, add the thing. It's not like the compile debug cycle where you stop everything, recompile, etc. There's nothing like that. You can just add systems on the fly, add things on the fly, which seems a little weird at first, but something you get used to very quickly. Saves time. You have a process. I'm using the term process very loosely. What it is it's not process in the concept of a business process. It's a flow of data. Let's call it an integration flow. A flow of data across different running services on different peer servers, right? That flow is referred to as a single integration process. Let's use the term integration flow. You can distribute the integration flow across multiple machines from a central location without re-engineering the process, the flow in any way. You can just say, run this component on that peer, run that component on that peer. Then you can say, okay, I want you at runtime to move this component to the other peer because this peer is getting too loaded. So again, all these things make a huge difference in practice. It saves you a lot of time. When something's getting overloaded, you know, you get alerts. Right? These are sort of the kind of things that enterprises are looking for. There's a microservice development SDK. You can develop in multiple programming languages. There's automatic code generation, sort of like Visual C++ if you're familiar with that. The original Visual C++ tools released by Microsoft. You click a button and it generates the sort of skeleton code for the service. You just type in the business logic and you're ready to go. You click a button and everything appears in the studio. So you essentially can create your own services, your own microservices in the form of these Lego blocks and create your own categories and start using them, right? And at some point in the very near future, we're also going to be announcing a sort of a microservices gallery where developers can publish their microservices and you know, sell them on a commercial basis. Sort of become like iTunes for microservices, call it that way, call it that, right? There's no requirement for an external process persistence database with the Fiorano ESB. This is because the state of the integration flow is not stored in a database. The state of the system is in the messages that are flowing across the system. So let's suppose the power goes out. Well, guess what? The messages are still there. They're all persisted, right? When the power comes back, you start off where you left off. There's no sort of concept where you're going to keep writing the state to a database. And then, if there's a power issue, then you're going to read from the database. Some messages were missing, and then you're going to replay the transactions. None of that stuff. Right? Now, of course, there's a full high availability architecture, et cetera, with redundant servers running, and so if the power goes off, you switch to the other servers. All that is there. It's a separate issue. That's more part of the professional edition of the product. But that the point to understand is that the asynchronous nature of the integration flows means that you don't need a database of any kind. So if any of your managers asks you, where's the database, you don't need one. And you look at you like you're a bit of a zombie, but tell them you're not. Tell them that's the real technology. It's been around for many years. Right? So there's a lot of learning. Ultimately, all of these things, when you look at the product and the tools, there's just one view. Create the flow. There's no other view in the system. It can't get simpler than that. Right? And when you drag and drop two components and draw a line between them, you're essentially like creating a JMS queue between two existing JMS applications. So it's nothing but think of the Fiorano ESB as distributed messaging with really cool tools which allow you to visually set up an asynchronous flow across the entire network and monitor it easily and check various performance and change things at runtime and modify them. So that sort of gives you an overview. I mean, very short overview, but there are lots of features packed into the system, and all of them are available essentially. You can download the product and use it. The tools are available with the community edition. Some of the adapters are licensed, and a lot of them are open source, and a lot of them are free, and some of the top-end adapters, and all the information is on the website. It's like a traditional thing. So the packaged adapters, they're all available, and you can play around with the system. So why open source? It's proven technology. It's actually a commercial product that's going open source and not the other way around. It didn't start off as a project that went open source and people made a lot of money consulting on it and just kept improving it. That's not what we did. It's a proper enterprise level product that has been used by some of the biggest enterprises in the world. It's being actively used, and it's exactly the same technology. There's a very good support system around, global support system, and that's something that is you're going to have to experience yourself. There's a quote there from one of our fairly big customers, and so there you have it. Why don't we go ahead and
thanks. Yeah, thanks very much, Atul, for that, and I'm sure we are going to have some questions here. We'll give everybody a couple of moments to type in a question, and then we'll get those answered as quickly as possible. The first question, I think this is, the first question is regarding different connectors. I don't have the full question, but hi, the open source version, do you have the different connectors? And this is from Yuri Kalinov. Atul, you want to handle that? The availability of the various connectors that adapt?
Yes.
Yuri, if we got that right, let us know.
We do have a connector T24. The T24 connector is available as a priced option on the open source version. So the T24 connector itself is not open sourced, but it can be, you don't have to buy the commercial version to get the T24 connector. It's available for a reasonable price, but it is one of those things that is priced.
And I think, Atul, you might want to also comment on the other connectors in our products. adapters?
Yes, there's about 12 or 14 high-end adapters that are priced, including database, SAP, Fix and Swift, some financial adapters, and I believe the FTP and SMTP adapters. So the exact list is on our website, but all of the transformation adapters are free, and there's a whole bunch of very free adapters as well. There is a Salesforce adapter available, yes. There was just another question there.
Yeah, we have a second question from Jeff Davis. I think we all know who Jeff is. And Jeff said he joined a little late, but he was wondering what the underlying technology stack used for microservices. Is it Docker, Cloud Foundry, which one? I know the answer to this, but I'll let you answer that, Atul.
We don't use Docker. What we mean by microservices is that the Fiorano services, when you create a Fiorano service, they satisfy all the requirements of a microservice. It's coarse-grained, it's fully self-contained, it has all the dependencies in it. It has, if there's a database dependency, it's in that service. It has independent inputs and outputs. It's like a sort of pipe. Right? Each service can be written in a different programming language. So the Fiorano service satisfies all of the requirements for what people are calling microservices. So Fiorano itself is the container in the sense that it sort of is an alternative to Docker. We did have a webinar about this, Jeff, relating to Docker, which we will actually send you a copy of the webinar, and a lot of it is covered there.
Thanks, Atul. And then another question, Atul, about availability and differences. What are the differences between the open source ESB product and the full commercial version?
There are only two big differences. The commercial version has the high availability architecture and the multi-pair architecture. So that's one difference. And second, the commercial version is bundled. There's more connectors available in the commercial version, but those connectors can be purchased as options even on the open source, on the community version. So from a runtime standpoint, there's no difference in terms of the connectors, except there's a price involved. With the open source version, so you can get the open source server, use the tools, and just buy the connectors essentially. And the connectors that you need. So if you're just doing database-to-database implementation, just buy a database connector, right? If you don't need high availability and a lot of scaling, you're really good to go with the open source, with the community server and the 1 or 2 professional adapters.
Okay. And if you have any further questions, I think we can take that offline and answer those more fully for you. The next question, again, is relative to the product tool. Is MQTT supported with the open source or community version of Fiorano? And that's from Declan.
Yes, actually MQTT is supported. Fiorano actually has its own MQTT implementation. We don't have the MQTT open source just yet, but it is supported in the sense that you can connect to an MQTT system or build a client to an MQTT as a service in the ESB.
Okay, great. We've got quite a few questions to go through. This is from Maxim, and could your solution automatically route to standby applications in the prime if the prime instance is unavailable?
Yes, absolutely, absolutely. The high availability architecture allows for that. That is available only in the commercial version, in this sort of professional version. But that's in fact the big difference. Really, the only difference between the entire community version and the professional version is the high availability architecture and the multi-peer architecture, right? Otherwise, the systems are exactly the same. If you've got a small project, in all honesty, you can just use the community version and get a few adapters and support if you need it.
Another question about the product, given, and this is from Neil, given well-working TCP/IP lines, which kind of end-to-end responses involving, say, 10 microservers could be expected? And this is from Niels Bongard.
Are you talking about speed? If the discussion is about speed, we've been tested it over, it depends if you just have an internal network. We've tested it over 2,000 messages per second, responses per second, but it really comes down to the network, the hardware you're running on. It's asynchronous, right? So you could set up 5 pair servers and just have, 1 to 2, 3 to 4, 5 to 6, 7 to 8, 9 to 10, and everything running in parallel, right? So things are, you can scale your speed linearly on a single, say, a single system. It's really as fast as JMS, which is very fast.
Okay, thank you for that. And another question from Mr. Jeff Davis. Does your Java SDK for microservices use Spring Boot?
I believe it does, Jeff. We will have to re-verify with you offline, but my understanding is that it does.
Thanks. And another question from Nils. How is your support organization in Europe for a Denmark-based corporation or operation?
The support is from Europe is based out of the UK, but Nils, it shouldn't be a problem. Just try to use our support, and we're pretty sure you'll be satisfied. We're well known for that. We've got a lot of customers in Europe, and they're all very happy with our support.
And I've got 2 questions here from Steve Doney. Can an open source app be used or imported on the full version? His first question. And the second question, are the release levels of source and full the same?
The answer to both is yes. You absolutely can. The open source app, when you build it and you want to move to the full version, there's no problem at all. Right now, the release levels are exactly the same, and there may be a bit of, depending on how many releases we make to the open source, there may be a bit of difference at times, but the goal is to try to keep it as close as possible.
Thank you. And another question, this is from Kevin Pereira. Kevin's question is, we've seen some challenges with some of the open source platforms when putting support for production environments. In particular, some are charging for official support on a per CPU basis, making production support on a par cost-wise with the likes of IBM and Oracle. What is the Fiorano approach to providing production support?
Right now, the approach is similar, but with a much more reasonable pricing structure. It really comes down to the price, and there has to be a way to sort of price the support based on the size of the deployment. And we've come up with a structure that makes it significantly more attractive than a lot of the existing open source products, because the support is really the key model here from a business standpoint. And we're looking at least a 50 to 60% price reduction in comparison to existing open source.
Thanks, Atul. Another question from Steve Doney. Are the release levels of open source and full the same? I think we've answered that already. They are. And from Maxim, is it possible to into oh, I think it's a mistype here. We got a typo. But is it possible to introduce Fiorano logic with check authenticity of the message and authorize it before sending out to the recipient?
I believe it's possible. You may have to write a specific component for
the check.
For that. We'll have to check on that, but it is possible to achieve this functionality fairly easily.
Yeah, I think I think we have customers that actually do that. But we can get back to you with specifics, but I do believe we have.
We can actually get back to Max and make a note of that.
And from Christopher, we have, what technologies do Fiorano use or recommend regarding high availability in the commercial product? Thanks. With commercial product.
Well, we usually recommend the use of it depends whether you want to use shared high availability or replicated. If it's replicated, you can just use two separate machines. Regular servers will do. Use two separate, let's say, 4 CPU machines, right? And when you're writing data, we write to the backup instance first and then to the primary instance, so everything is all synchronized. So that's the approach right there. And you don't really need any specifics. If you want to use shared HA, where you're sort of sharing the data store, then you need a SAN device, and that's something that's all this information, Christopher, is actually available in the documentation, and we'll make a note and actually send you a link to the particular part of the documentation where the relevant information is available.
And then finally, at least for now, another question from Nuko. So the open source version is free to use, which we know is correct, and yes, right away, and no, there are no deployment licenses. So the question is it ready now, and are there no requirement for deployment licenses?
That is correct. There's no requirement for deployment license. There is a license for the tools and the commercial adapter. So the commercial, when you download the product today, you get to use the whole thing. And there are some adapters in the palette that are commercial adapters. Those will only work for 60 days, but you're free to use the tools and the product and anything else and build your own services right out of the box. There's no problem. Absolutely. So, if you use the SAP adapter and then it stops working after 60 days, you can't expect that to work, right?
And those are basic license issues.
Yeah.
And then we have another question here from Humphrey Mora. For Africa, specifically in Nairobi, Kenya, where there is intermittent internet connectivity, do you see any challenges with the use of open source ESB?
No. The runtime is set up in a way that it reconnects. So if there's an intermittent failure, it'll pick up where it left off. Having said that, if you have distributed locations and you need sort of multiple peers, then you will need the sort of professional version. But it's the exact same product of peer-to-peer connectivity, but that also works across intermittent networks, so that if there's network failure, we will pick up where we left off when the network's back again. It's a very key feature of the asynchronous architecture.
So we're running up to time. We've got about 5 minutes left. I don't know if anybody has any other questions. We'd be happy to answer additional questions, so we'll take 30 seconds to see what comes up. In the event that we have no further questions, we would again like to thank you for joining us today. I hope you found the discussion informative. I think that this is an excellent opportunity to use a very proven product, a commercially proven product in an open source setting. So we encourage you to download the product. Again, all the information for downloading the product is available, and you can also get the information with a recording of this presentation from the website, and of course available through Intellyx and Jason's company in the event that you would like to download some of his information and any additional information that can be provided there. So we don't currently have any questions. Oh, is there a web link for the download? There we have it. And yes, there is a link, and we'll send that out, and it should be on the page. So we will make sure that we get that sent out to all the attendees as it is. The next question is, and this is from Anuko again, so adapters can actually be built and sold on the marketplace. Atul, you made a comment about that.
Yes. The marketplace is something we haven't actually got on the web yet, but it's going to be coming up shortly. The idea is it's going to be exactly like, suppose you're an artist writing recording a song and you put it up on iTunes. Anybody can sort of download it from iTunes and play it, right? So if you actually build a microservice and test it with Fiorano, and you can put it on the marketplace, and anybody can buy it, and then you get the money for it, and there's a business structure around that. So you build it using the toolkit that you get with the open source product, right? You can actually build adapters right now with the open source product and market them yourself. So that is something you can do right off the bat.
And a couple of, I think, one more question. Can you please expand on the implementation of T24?
Well, the T24 adapter is available, but it's a commercial adapter, so you can use the open source version, but you do have to purchase the adapter, as I had explained earlier.
Yeah, and that's a commercial relationship with
yeah.
There's nothing we can do about that.
Yeah. If you want to actually build one yourself, then you have to get access to a Temenos T24 system. It's not something that we can help with. We've built our own T24 adapter because we have a commercial relationship with T24. I thought the question was relating to the fact as to, what do you do with our T24 adapter, in which case you'll have to license it. Right. So we do have an adapter, yes, and so that's the thing.
And we have another note here from Nan Asakaran, and it's how can the community contribute code?
The process is really based on the GitHub process. There's a whole, the sources are on GitHub. You can download them from there, and if you want to contribute, you can contribute through the process that's outlined at GitHub. So best would be to check that.
And then I think we may have answered Naim's question, do you have an adapter for Temenos? And we do. But again, that is a licensed product. It's not free with the community version.
That's right.
So very good. So we're running right on the hour. Unless there's another question coming up quickly, again, we'd like to thank you for attending. Again, through our website, the downloads are available. We will be sending out notes to all of our attendees with download instructions for your convenience. And we're hoping to talk to you soon. So thank you very much for attending, and have a great day. Thanks to Atul, Jason, and the rest of the team. Thank you very much. Bye for now.
Thank you.